forms, what their patterns are, how we predict them, and how you can avoid being killed by them. This is the Hurricane Update. Thanks, Clay. Now, to start off our show, we'll start with a viewer question.
How do hurricanes form?
I call upon the rain gods for sustenance! Not like that. More like this. How do hurricanes form? Well, due to low pressure gradient force, when warm low pressure air rises, cool high pressure air moves in underneath it. This force, along with atmospheric pressure at work in a low pressure center, are the ingredients for a hurricane. When a hurricane forms, this is basically what happens. Warm air from the ocean begins to rise rapidly and the water vapor starts to condense in storm clouds. This process releases heat called the latent heat of condensation. This latent heat warms the surrounding air, causing it to rise. This rising air is then replaced by more warm air coming from the oceans below. This cycle continues on, causing a pattern of wind that circulates around the center. Converging winds on the surface collide and add to the cycle in pushing up more warm air. This causes circulation and wind speeds to increase. Higher up above 30,000 feet, high pressure air that is over the storm center also aids in removing heat from the rising air. As it moves into the low pressure center, wind speeds are increased. Combine all these factors and you got yourself a hurricane. And now for everyone's favorite weather clown, Jack Brown. I thought you were going to be old and hate children. Hey mister, where do hurricanes get their strength and energy from?
That's a good question, Billy. So, where does a hurricane get its energy and strength? Well, just like the solar car I'm driving, the atmosphere is powered by the sun's energy. So the sun's rays hits their surface and the energy is absorbed into the crust and into the water on their surface. This water then heats the surrounding air and powers the atmosphere. This warm air then rises into the upper atmosphere, beginning the cycle of warm and cold air. The sun does not distribute its power equally, however, and the area towards the equator receives a surplus of solar energy. This creates an imbalance between the northern and southern latitudes. The Earth's currents keep everything in check by forming what is called a Hadley cell. A Hadley cell is a huge area of convection, which causes warm air to rise into the upper troposphere and towards the colder poles. Once the air reaches the upper middle latitudes, it is forced down to the surface where it flows back to the equator, completing the cycle.
When are hurricane seasons?
A hurricane is formed when the cycling process lacks the efficiency to keep the transfer of air between the poles of the equator. Theoretically, the circumstances for hurricane formation is always present somewhere on the planet. It just depends on when the circulation system fails and when the right conditions are presented. The most popular time for hurricane activity is from June 1st through November. These months are considered the official season because they contain 97% of the Earth's tropical activity. The temperatures are warm enough in these months to produce the high-altitude warm winds that are an essential ingredient in a hurricane synthesis. Most hurricanes are formed from the tropical waves which form over the sub-Saharan Africa and continue over the Atlantic Ocean. Later in the year, hurricanes are more likely to form around the Caribbean and the Gulf of Mexico.
Thanks, Jack. Now, let's hear Clay's explanation on the ITCZ and pressure ridges. Hurricanes usually form due to a phenomenon known as easterly waves. Easterly waves form within 5 to 15 degrees of the equator in the ITCZ, or Intertropical Convergence Zone, where the trade winds converge, and begin in Africa, moving westward with the trade winds. The ITCZ, nicknamed the doldrums for its light winds, is an area of low pressure due to heating at the equator, which causes the air to rise. Easterly waves are formed when this low pressure protrudes outwards, which is caused by differential temperatures over a landmass. These waves increase in frequency during the warmer months since this difference increases. These waves at first have low amplitudes, causing only light rains, but with the right atmospheric conditions can increase in amplitude due to thunderstorms and high-altitude winds, and can create the convection and convergence needed for a hurricane. When the amplitude is higher, the winds form clearly defined ridges which curve around high pressure, and troughs which curve around low pressure. In order to balance the pressure gradient force and centrifugal force, the winds slow down when moving through a trough, and speed up when moving through a ridge. This causes the winds to condense at troughs, which causes air to be pushed up, forming low surface pressure, and to diverge at ridges, causing air to be pulled down, forming high surface pressure. This causes convergence and rising air downwind of the trough, which causes heavy weather, and sinking air and fair weather upwind, driving the convection cycle. This convection and convergence created along a trough creates the conditions needed for a tropical depression, or a weak low-pressure area, to develop into a tropical storm, and eventually, if unobstructed, a full-blown hurricane. Most waves do not survive long enough for this to occur, however, and those that do generally weaken until they reach the western Atlantic, where they pick up strength. In addition, not all of these waves travel in a straight line, as the Coriolis effect may cause them to curve upward toward North America and the U.S.
And now, Elizabeth Kim will give some facts about hurricanes.
First of all, there are 7 main things that you need to know about hurricanes. They have no fronts, the winds weaken with height, and the center is warmer than its surroundings. Hurricanes form under weak, high-altitude winds, and the air sinks at the center. The main energy source is latent heat of condensation, and lastly, a hurricane weakens rapidly over land. The surface winds of a hurricane blow inward in a counterclockwise direction toward the center. If you really want to be familiar with hurricanes, you must understand wind pressure, temperature, clouds, and weather patterns. No 2 hurricanes are exactly the same. And surface winds of a hurricane blow inward in a counterclockwise direction toward the center. Hurricanes are described in terms of left and right semicircles, or 4 quadrants. A line extended through the center of the cyclone towards the storm creates a division into semicircles. The left rear quadrant has the greatest angle of flow. The affected area by a hurricane ranges from a 25 to 100 mile diameter. The gale force winds can reach from 500 to 800 miles and up. The maximum extent of are strong winds in the direction of major subtropical high-pressure center.
So now, Clay is going to tell you a little bit about predicting hurricanes and how you can protect yourself.
Hurricane prediction is not an exact science. The only things we know for certain are that they tend to move in an east-west direction due to the trade winds, that they weaken and die out when hitting land or cold water, greatly limiting the possible paths they can take, and where and what time of year they tend to form. Due to the number of variables involved, however, it is hard to predict their actual path, though we can use satellite imaging to pinpoint their current position at any point in time. We use these images to spot possible hurricanes in their early stages, then use statistics to calculate probable wind intensity and the probability that each will escalate into a full-blown hurricane. From here we can predict a cone of possible paths it can take, which grows narrower the closer it gets, thus decreasing the margin of error. Many different models are used to predict changes in direction. Up until the 1980s, the CLIPER, or Climate and Persistence Model, which compared current data to past seasons, was used, though it is now used mainly to test new models. Today we use more models like BAM, Beta and Advection Model, which use current data from planes that fly into the eyes of hurricanes. There are many things to remember when preparing for a hurricane crisis. Meteorologists can usually predict a hurricane's landfall 3 to 5 days in advance. If you are in the way of this predicted path, start preparing early. Stock up on food and fresh water and other essentials such as a first aid kit, and have a battery-powered radio on hand. Be sure to have a secure room, if not underground then on the first floor. Bring all unsecured items in your yard inside that you can, and secure the ones you can't. Prepare for an evacuation if one seems likely, which includes making sure your car has a full tank of gas. If you live near a coast, river, or floodplain, or live in a mobile home, high-rise building, or on a hill where erosion might destroy the foundation, or if you're instructed to do so by the authorities, evacuate immediately. Do not try to wait it out. If you are forced to stay where you are, stay inside, seal up doors and windows, and reinforce your windows with wood or tape. Stay up to date via radio, stay smart, and stay safe. And now, on a more somber note, we have a special guest tonight. An anonymous survivor who has apparently experienced every Category 5 hurricane in the past 50 years. Which hurricanes do you remember the most clearly?
Well, in 1992, Hurricane Andrew came around and swept out like the whole entire Florida. Yeah, I heard migrant farmers there, like they all died. Well, I mean that's what I heard. It's a rumor, so I'm pretty sure probably. I don't know if that happened or not. Yeah, when I came back and tried to find my house, I couldn't find it because it got swept away. I mean, maybe I missed a block, but then I realized, yeah, there are no houses there, so yeah, I'm pretty sure it wasn't there. And in 2005, Hurricane Katrina came around. That was pretty bad. Like, people were sitting on top houses because they needed to escape the water. Yeah, I wasn't there either, but my house was there. I don't have that house anymore because, you know, it got destroyed, and some other kids from those, you know, those people that do things for other houses, they came and built another house there. It wasn't mine. So I moved to New York. I had a better life over there. No hurricanes, just snow. Basically. That's my kid over there. I gotta get him.
Well, that's all, folks.